Alright, so we're going to discuss congruent chords and arcs. We're going to use this picture here to fill in our notes. So, two chords that are congruent if and only if their corresponding arcs are congruent. Their corresponding arcs are congruent. Remember the equal with the squiggly means congruent, and hopefully you remember that congruent means equal, the same. This means that we can say, like over here, we can say segment AB is equal to CD. So this piece right here would be the same as this piece right here, which means that the measure of arc AB, AB with the swoop over it, is equal to the measure of arc CD. That means that this arc out here is going to be the same as this arc out here. So as long as you have one or the other, you notice the arrows go both ways, it works either way in reverse. B, they are equidistant from the center. So they have to be the same distance here from the center. They are, and that's equal distance, equidistant. From the center. Which means that AB is equal to CD, and both ways, EF is equal to EG. Okay, so this is equal to this piece here. All right, if the diameter or radius is perpendicular (90 degrees) to a chord, then it bisects, cuts in half, the chord. Remember, a chord is a line that goes from one side of the circle to the other. It doesn't go outside the circle. And its arc. Okay, so that would look like EH, segment EH is perpendicular to AB, AB, which means AF is equal to FB, which means the measure of AH, arc AH, is equal to the measure of arc HB. Okay. So because you have EH is perpendicular, okay, to AB, so it makes this right angle here. AF is equal to FB. Okay, that means that these two pieces here are equal to each other. Okay. Let's go ahead and look at our next page here. We're going to find X, find the indicated value. So we're going to use what we just talked about. If the two chords are equal, that means they're equal, then the arcs out here, this arc is equal to this arc. So these are equal to each other. So now I know that 7x plus 24 is equal to 115. And I can solve. So now it's back to solving equations. Subtract 24 from both sides. 7x is equal to 91. Divide both sides by 7. X is equal to 13. And we were looking for x, so we're done there. Make sure you check to see what you're looking for. Okay, so why don't you go ahead and pause, and I want you to try 2 and 3, 4, 2, 3, and 4. All right, here are 2, 3, and 4. Please check your work. The biggest thing is remembering here that you're looking for x, y, and here you're looking for the measure of arc RS, so you have to plug back in when you find x. Okay? You can pause this if needed to get the work done and get the checking done. Let's go ahead and look at 5. We're going to find x here. So now what we know is we have our 6x minus 20 here. We were 76 here. I know that this piece and this piece are the same. So I'm going to do a little work. I don't know either of these, so I can't just subtract 76 from 360, but I know that this is 6x minus 20. I know the whole thing is 360, so what I'm going to do is I'm going to take 6x minus 20 plus 6x minus 20 plus 76 is equal to 360. So I know all of the pieces together equal 360. So that will give me 12x, get 76 plus 36 equals 360. I'm going to take away 36 from both sides. 12x equals 324, divide by 12. X is equal to 27. And we were looking for x, so that's our final answer. Okay, so if NP is equal to 5x minus 34, PN is equal to 2x minus 4, we're going to find NP. So we're going to have to plug back in after we find it. With these perpendiculars, we know that this is equal to this from our notes earlier, because that is also equal to these pieces. So I can say this here is 5x minus 34. I can say from what we have 2x minus 4. So NP is equal to PN. So 5x minus 34 is equal to 2x minus 4. Add 34. 5x is equal to 2x plus 30 minus 2x. 3x is equal to 30. Divide by 3. Sorry guys, and that's moved over. X is equal to 10. That is not what it asks us. It asks us for MP, so I got to plug back in the 5x. So 5 times 10 minus 34. So MP is equal to 16. That's my answer. Box them off so you have them quickly. All right. Anytime you need to, you can pause this video to help get you caught up. All right, so I want you to try 7 and 8. So go ahead and pause, try 7 and 8. All right, there you go. There is 7 and 8. If you have any questions or you need a minute, go ahead and pause. All right, we're going to look at 9 and circle Z. If RS is 18, it is good to label these as you go. This whole thing is 18. The measure of arc TY is going to be 42. This is 42. This is 42 then. This is 42. We talked about that in our notes in the beginning. If RS is 18, we've got 9 and 9, 9 and 9. A little bit there. Let's see, RS is 18, so this is 9. This is 9. This is 9. This is 9. Which also means that see, TV is 9, TU is going to be 18 because it also equals RS. And this also equals BU plus many more. WS is 9. Okay. Measure arc YU. YU is 42. Remember that all these little pieces are the same. 42 degrees. RS. Arc RS is going to be 84. You have to add the two together. 84 degrees. Okay, I would like you to pause it, and I would like you to try number 10 on your own. All right, if you take a look at 10, I tried to put a little extra work into there. They gave me the 256 here. I did a little work to get all these little pieces here. Once I got that, I knew these two were the same, divided by 2. These two are the same, divided by 2, so I had them all. This should still total 360 when you're done. Because BG is 17, that was only half. I got my 17s all in there. If you have any questions, make sure to bring them to class here. Okay, we're going to keep going. 11 and 12. Let's go ahead and take a look at 11 and 12. Okay, 11. QM. QM. This part right here is 6x minus 11. And then MR, this part right here, is going to be 2x plus 9. Well, I know that all of these pieces here are equal, so I know that those two are equal. So I can go 6x minus 11 equals 2x plus 9. Do a little work. Excuse me there. 6x equals 2x plus 20 minus 2x minus 2x. 4x equals 20, divide by 4. X equals 5. Now it said find MN, so we are looking for this whole length here. So I'm going to plug back in. 2MR is equal to 2x plus 9. So 2 times 5 plus 9, so it's 19. MN is equal to 19 plus 19, which is 38. Okay. If the measure of, this is a good one, why don't you go ahead and pause and try this one. Okay, after getting a little look at this one, I'm going to go ahead and work a little bit with you on this one. I've got my picture filled in. I know that this is 12x minus 8, 7x minus 15 according to this. They both are. I know that arc CD and arc EF are equal. So I'm going to go ahead and add these together. So I get 14x minus 30, because I need the whole arc, is equal to 12x minus 8. Now I can solve. 14x plus 12x plus 22 is 12x. 2x equals 22, divide by 2. X equals 11. Okay, that's not what we're looking for though. We are looking for the measure of arc CI. So that's this one here. So we're going to plug back in. Is 7x minus 15. So it's going to be equal to 7 times 11 minus 15, which the measure of arc CI is equal to 62 degrees. Okay. Now we're going to go ahead and look. It says use the circle below for questions 13 and 14. So on this one, we're going to use this circle for both of these problems. We are going to bring back little SOHCAHTOA. do not panic. We are going to use a little bit of Pythagorean theorem. It says find VW. So we're looking for this whole side right here. I have a 5, a 13. I'm missing the side length here. But if you cover everything else up, that means if I get rid of all this, you should see a right triangle in there, which means we can use Pythagorean's theorem. So we can use a squared plus b squared equals c squared, where a, b, and c. So 5 squared plus b squared equals 13 squared. Do a little work. B squared equals 144. Square root both sides. B is going to be equal to 12. So this side right here is no longer b. Now we can call this 12. And we know, because of this perpendicular, that these two are equal. That's 12. So if we're looking for VW, it's equal to 12 plus 12, which is 24. Okay. Now we're going to find the measure of arc YW. Okay. This is where we're going to use, because we're looking for an arc, which is an angle measure technically. So if we come and look at YW, we're looking at this one right here, which is essentially this angle measure in here. So what you're going to do is, because we know these are the same, these little measures, we're going to look at it like this. This is the angle measure that we're looking at. We know that we got 5, we know that we got 12, and we know that we got 13. So I told you we're going to use a little bit of SOHCAHTOA. And really, you're going to be using your calculator for this, and you're just going to use the inverse button. Okay, so what we're going to do is we're going to, and this actually can be done several different ways. So we're going to look at it as, if we're looking for this, we are going to do the, I'm going to use cosine. You could actually use, because you have them all. I'm not going to use this one because I just found it, and what if it's wrong? So I'm going to use the adjacent side and the hypotenuse, which is the ca part. So the cosine, and we can call this y here, of y, is equal to 5 over 13. What we do is we go cosine inverse, remember that button on your calculator, 5 over 13. So we know that it's going to be 67.4 degrees. So the measure of arc YW is that, because that was the measure of that angle, and that angle just comes out. I do suggest that you redraw this out separately. It will help you to find it. So go ahead and pause, and I want you to try 15 and 16, very similar to 13 and 14. Okay, so there is 15 and 16. If you have any questions, please bring them to class with you. The most challenging part probably is going to be remembering to bring back that SOHCAHTOA, and really these last couple of problems that we just did. We'll have some more practice with them, so don't worry. If you have questions when you're working through those in your homework, I can answer those.